Students, find out hybridization given following organic molecules. Student, find out hybridization given following organic compounds. That is, first one is ethane. So we know, student, what is the hybridization? So 2 sigma bonds are there. What I said, 2 sigma bonds, that is sp hybridization. 3 sigma bonds are there, that is sp2. In case 4 sigma bonds are there, that is sp3. This is the we know, student. And one more thing, student, single bond also having only one sigma bond, double bond also having only one sigma and one pi bond, and triple bond also having only one sigma and 2 pi bond. So generally hybridization depends on number of sigma bond. Hybridization depends on number of sigma and lone pair. You remember, student, number of sigma bonds and lone pair. Hybridization depends on number of sigma bonds and lone pair. I will give simple trick, student. This carbon surrounding, how many sigma bonds are there? I am writing skeleton structure, student. This CH3 single bond, CH3 skeleton structure I am writing. This first carbon, this is second carbon. First carbon surrounding only 3 hydrogens are there. So one hydrogen here, 1, 2, 3. Then after that single bond is there, then single bond. The right side carbon also having 3 hydrogens, 1, 2, 3. What I said, student, that hybridization depends on number of sigma bonds. In this first carbon, hybridization depends on number of sigma bonds and lone pair. So in this first carbon, this is first carbon. This first carbon surrounding, how many sigma bonds are there? This first carbon surrounding 4 sigma bonds are there. That means this carbon surrounding 4 single bonds are there. 1, 2, 3, 4. So 4 single bonds equal to 4 sigma bond. Here also 1 sigma, here also 1 sigma, here also 1 sigma, here also 1 sigma. 4 sigma bond, what I said, 4 sigma bond carbon is undergoes sp3 hybridization. This is sp3. And what about second compound, student? This carbon surrounding also same thing. This carbon surrounding 4 sigma. Here also 1 sigma, here also 1 sigma, here also 1 sigma, here also 1 sigma. So it is also undergo sp3 hybridization. This is the simple trick, student. This middle bond belongs to both carbons. This carbon counting, if in case asking this carbon hybridization 1, 2, 3, 4, this carbon also count this sigma bond, and this carbon also count this sigma bond. This middle sigma bond, both are counting. Both are counted. So this is the simple trick for hybridization, student. Now take the second example. This carbon surrounding 1, 2, 3, 3 sigma bonds are 3 carbons are there. Each carbon hybridization. This first carbon, second carbon, and third carbon. I am writing skeleton structure, student. This carbon surrounding 3 hydrogens are there. 1, 2, 3. Then CH here. This carbon only 1 hydrogen is there. After that double bond is there. 1, then 2. So this is first carbon. This first carbon surrounding, how many sigma bonds are there? This first carbon surrounding, how many sigma bonds? Here this carbon surrounding, here also 1 sigma, here also 1 sigma, here also 1 sigma, here also 1 sigma. So this carbon undergoes this carbon surrounding 3 sigma bonds are there. So 3 sigma bonds are there. That hybridization is sp2. This first carbon undergoes sp2 hybridization. What about second carbon, student? This second carbon surrounding, how many sigma bonds are there? Here also 1 sigma, here also 1 sigma, here also 1 sigma. What I said, pi bond also having only 1 sigma. So this second carbon surrounding 1, 2, 3. It is also undergoes sp2 hybridization. And what about third carbon, student? This third carbon surrounding, how many sigma bonds are there? This third carbon surrounding 1, 2, 3, 4. So total 4 sigma bonds. So this is sp3 hybridization. So you remember, student, this middle bond counting both carbons. This carbon also counting, this carbon also counting. So this middle carbon, this middle sigma bond, this middle single bond is that this single bond having only 1 sigma bond. This sigma bond counting with first carbon and second carbon also. This is the simple trick, student. So first carbon undergoes sp2, sp2, and sp3. So this is sp2. This is also sp2, this is sp3 hybridization. This is a simple trick, student. Now third example, student, I am writing skeleton structure. Third example, skeleton structure. This is surroundings, this carbon surrounding 3 hydrogens are there. 1, 2, 3. Then after that carbon, this carbon surrounding 3 bonds are there. Then after that this one. So each carbon hybridization, student. This is first carbon, this is second carbon, third carbon. First carbon hybridization, this carbon surrounding, how many sigma bonds are there, student? This carbon surrounding 1 single bond is there, 1 triple bond is there. You remember, student, single bond also having always only 1 sigma bond, triple bond also having always only 1 sigma bond. You remember, double bond always having only 1 sigma bond, triple bond also having always only 1 sigma bond, and single bond also having only 1 sigma bond. So this first carbon surrounding only 2 sigma bonds are there, 1 sigma right hand side, 1 sigma left hand side. So this hybridization is sp. And second carbon, student, this carbon surrounding left hand side one single bond is there, right hand side one triple bond is there. You remember triple bond also having only one sigma, so here also one sigma, here also one sigma. This is also undergoes sp hybridization. And what about third carbon, student? This carbon surrounding 4 sigma bonds are there, one sigma from here, 1 2 3 4, so this is also sp3 hybridization. This is the simple trick for hybridization, student. This is a simple trick for hybridization. Now next one, fourth example, student. I am writing here fourth example, CH3 CH2 plus. This is first carbon, this is second carbon. First carbon and second carbon hybridization. So this first carbon surrounding, first I am writing skeleton structure, student. I am writing skeleton structure. This carbon surrounding 3 hydrogens are there, bond. This carbon surrounding only 2 hydrogen, here also 1 hydrogen and here also 1 hydrogen, that positive charge is there, deficiency is there. So what I said, student, this carbon surrounding how many sigma bonds are there? This carbon surrounding first one, this is first carbon, this is second carbon. First carbon surrounding how many sigma bonds are there, student? 1 2 3. So this is sp2 hybridization. Plus means that is deficiency, there is no electrons, so that is not considered. So this carbon surrounding only 3 sigma bonds, left hand side 1 sigma, down right hand side 1 sigma, downwards 1 sigma, so 3 sigma bonds are there, so that's why it is sp2. And what about this carbon, student? This carbon surrounding 4 sigma bonds are there, 1 sigma here, 1 2 3 4, so it is also sp3 hybridization, sp3 and sp2. This is the simple trick for hybridization, student. Now take the one more example, student. Now take the one more example, CH3 CH2 minus. I am writing here, student, this structure. This carbon surrounding 3 hydrogens are there, 1 2 3, then bond. This carbon surrounding only 2 hydrogens and here minus is there. So this first carbon, student, this carbon surrounding 1 sigma bond here, 1 2 3 and minus means it contains 2 electrons. What I said, student? You remember, student, this carbon surrounding 1 single bond is there, here also 1 sigma, here also 1 sigma, here also 1 sigma, but this minus means what means? This negative charge means what, student? That is negative charge, it contains 2 electrons. 2 electrons means 1 lone pair. What I said, student, 1 lone pair equal to 1 lone pair. So you remember, student, 1 lone pair equal to 1 sigma bond. You remember, sir, 1 lone pair equal to 1 sigma bond. That means negative charge is there, that negative charge is equal to 1 sigma bond. You remember, negative charge is there, that is always it contain only 1 sigma. If in case lone pair is given, lone pair equal to 1 sigma bond, negative charge equal to 1 sigma bond. Negative charge means this bond contain 2 electrons. This bond contains 2 electrons, the 2 electrons equal to 1 sigma bond, you remember, student. So here this carbon surrounding, here also 1 sigma, here also 1 sigma, here also 1 sigma, and 1 lone pair equal to 1 negative charge equal to 1 sigma bond. Total 4 sigma bonds are there, that is sp3 hybridization. This is very most important, student. What about this plus means there is no deficiency, there is no electron, so that's why that is not considered. But CH2 minus means minus equal to, that means negative charge equal to 1 sigma bond, or lone pair equal to 1 sigma bond. So here this carbon surrounding, here also 1 sigma, 1 2 3, and negative charge also 1 sigma bond, so total 4 sigma bond compound always sp3 hybridization. And what about this carbon, student? This carbon surrounding also 4 sigma bonds, here also 1 sigma, 1 2 3 4, so it is also sp3 hybridization. This is a simple trick for hybridization, student. Now take the one more example, very most important, that is CH2 double bond CH, then CH2 plus, then CH2 double bond, then CH, then CH2 minus, then one more example, CH2 double bond, then CH, then single bond, then CH2 minus. Calculate the hybridization, that is A and B and C. Out of these 3 compounds, calculate the each carbon hybridization, student. So we know, I am writing skeleton structure, student. I am writing skeleton structure. CH2 double bond means that is this carbon having 2 hydrogens, double bond, 1 hydrogen, single bond, like this. So this carbon surrounding 3 sigma bonds are there, 1 2 3, so that means sp2 hybridization. And this carbon also surrounding 3 sigma bonds are there, 1 2 3, this is also sp2 hybridization. And this here plus C is there, plus charge is there. So this carbon surrounding 1 2 3, it is also sp2 hybridization. So in this structure all carbons undergoes sp2. this is also sp2, and this is also sp2, this is also sp2. And one more thing student, this conjugation is there, double, single, positive conjugation is there, this positive charge participating in the resonance. One more thing, so all carbons will undergo sp2 hybridization. Why? Because of this carbon surrounding 3 sigma bonds, 1 2 hydrogen. Remember, so 2 hydrogen, 2 sigma, here also 1 sigma, 3 sigma bond, 3 sigma bond, that is sp2. And 1 hydrogen equal to 1 sigma bond, 1 pi bond also 1 sigma bond. So total sp 3 sigma bond, here also sp2, and here also 2 hydrogens equal to 2 sigma bond, 2 sigma bond plus 1 pi bond, 1 pi bond also having 1 sigma bond, 2 plus 1 3 sigma bond, this is also undergoes sp2. So in this compound all are undergoes sp2 hybridization. Now take the second example student. I am writing second example student. Here CH2 single bond, Cl single, then double bond. This carbon also having 1 hydrogen here, put the 1 hydrogen here, and this carbon also 1 hydrogen here, 1 hydrogen here, 1 negative charge is there. Simply remember student, this carbon undergoes, generally we are thinking negative, what I said student, negative charge is there, negative charge equal to 1 sigma bond. But you remember student, here conjugation is there, double bond is there, then single bond is there, this negative charge participating in the resonance. So this negative charge is not standard, that is delocalization, that is this negative charge participating in the resonance. This negative charge is participating in the resonance, so this is not permanent. So here this is not considered, this carbon surrounding only 3 sigma bonds, 1 2 3, so this is sp2 hybridization, and this carbon surrounding also sp2 hybridization, and this carbon also sp2 hybridization. What is the reason student? What I said before, that is negative charge is there, that always 1 sigma, but this negative charge is not permanent. Why? Because of conjugation is there, double bond then single bond, conjugation is there, that means this bond shifting towards here, automatically this bond shifting to here. So we get that is this carbon getting negative charge and CH double bond CH2. So this is not permanent, this bond, this negative charge is not permanent. So this negative charge participating in the resonance, the delocalization, that means participating in the resonance. So that's why this is not permanent bond. So that's why this is negative charge is not considered. So 1 2 3, that is sp2 hybridization. And what about this carbon student? This carbon surrounding, this is very most important student. I am writing skeleton structure. This carbon surrounding 2 hydrogens are there, like this. Here 1 double bond, then 1 hydrogen, then student, this carbon surrounding 2 hydrogens are there, 1 2 hydrogen, then this carbon surrounding 2 hydrogen and 1 negative charge. So this is very most important interesting question student. And generally this carbon surrounding 3 sigma bonds are there, here also 1 sigma, here also 1 sigma, here also 1 sigma, so it is sp2, this is okay. And this carbon surrounding also same thing, here also 1 sigma, here also 1 sigma, here also 1 sigma, it is also undergoes sp2 hybridization. And what about this student, what about this carbon surrounding? This carbon surrounding 1 2 3 4, it is also undergoes sp3 hybridization, sp3. Why? Because of this carbon surrounding 1 2 3 4, so sp3 hybridization. And what about this carbon student? This carbon surrounding also 1 2 3 4, is also sp3, this is also all are undergoes sp3. What is the difference between this compound and this compound student? You remember student, this compound and this compound, due to the resonance student, this negative charge participating in the resonance, so that's why it is unstable, participating in the resonance, so that's why it is the stable. So this negative charge participating in the resonance, this is not permanent bond. But in this C compound, double single, double bond, then single bond, then single bond, there is no conjugation. This negative charge do not participating in the resonance, this negative charge do not participating in the resonance, so that's why this is the permanent bond. So this is also considered as a sigma bond. So this carbon surrounding 4 sigma bonds are there, so that's why it is sp3 student. This is the simple trick for hybridization student. If you like my video, please like, share and comment. Thank you.